Same section as the last problem that I did. We're just trying to evaluate this expression without using a calculator. So the secant of pi over 4, so we did a little side work over here. Cosine of pi over 4 is radical 2 over 2. Therefore, the secant of pi over 4 is 2 over radical 2. So that secant of pi over 4 equals that. And then let's think about the cotangent of pi over 3. Well, we know the tangent of pi over 3 is radical 3, and therefore the cotangent of pi over 3 is the radical 3 over 3. So it's 1 over radical 3, and when you rationalize the denominator, you get radical 3 over 3. So we have that value there, and we have 2 over radical 2 there, which I guess we could rationalize our denominator. So we're going to get 2 radical 2 over 2. So 2 radical 2 over 2 is just radical 2. So that's our value for secant of pi over 4. So let's replace secant of pi over 4 with radical 2, and then let's replace cotangent of pi over 3 with radical 3 over 3. And there's not really any simplifying we can do. I suppose we could multiply top and bottom of this expression by 3 to get 6 radical 2 plus 4 radical 3 in the numerator, and we could get 3 in our denominator. Not a big benefit by doing that, but nevertheless, that might be the answer in the back of the book. Not sure. I'd be happy with you leaving it as 2 radical 2 plus 4 radical 3 over 3. That would be fine. All right, let's see what we have to do for number 47. Find the exact values of the 6 trig functions of the given angle. Well, we already know how to do this. Why am I doing this? Just so you guys can get some practice with the other trig functions, the reciprocal functions. So if it's 2 pi over 3, we're right there. We know that guy right there, so the sine of 2 pi over 3 is equal to, that's the radical 3 over 2, and the cosine is 1/2, and the tangent of 2 pi over 3, that's negative 1/2 for the cosine because it's in the second quadrant. Tangent of 2 pi over 3, that's the negative radical 3. So then if we go cosecant, I'm going to go cosecant of 2 pi over 3. I'm going to just put a dot because I'm tired of writing the 2 pi over 3. Let's do that. Cosecant is equal to 2 over radical 3. The secant of the angle is equal to negative 2. And then the cotangent of the angle is equal to negative 1 over radical 3. So that's those are our 6 trig functions of that same angle. And then we do the same with 3 pi over 4. And let's call 3 pi over 4 theta. So we can find the sine of theta, cosine of theta, tangent of theta, cosecant, secant, and cotangent. So that's a little shorthand here because the numbers are going to be really easy. Since we already know where 3 pi over 4 is, it's right there. And so the angle here, theta, we're trying to find the sine. Well, we know the sine is radical 2 over 2. We know the cosine is negative radical 2 over 2. We know the tangent is negative 1. Cosecant will be reciprocal of sine, secant, reciprocal of the cosine, and the cotangent, the reciprocal of the tangent. So there you have it. You didn't see that. So I cut that off. Let me back up a little bit. Okay, that's 4 minutes for that. I'll go ahead and do the 405 as well. So 405, we have to first figure out, well, what is that? Well, you go 360, so if you go 360 degrees plus 45 more, we're going to get to the 45-degree angle. So let's call that theta. And so we want the sine of theta, cosine theta, tangent theta. And then let's spell these out a little bit more. Cosecant, secant, and cotangent. So we know the sine and the cosine are the same, radical 2 over 2, because it's the same as the sine of 45 degrees, right? So the sine of 45 degrees or pi over 4 or whatever. Tangent's 1, cosecant 2 over, so the reciprocal of the sine. The secant is the reciprocal of the cosine, and the cotangent is also the reciprocal of the tangent, which would also be 1.